Hello, welcome to What's in the Molecule with Intermolecular Forces. Let's see what we got. So there's three intermolecular forces. You have dispersion. These are only the forces for nonpolar. So nonpolar molecules only have these forces. Dipole-dipole forces. Those are for all polar molecules. Polar molecules, in addition, have dispersion forces. They have both. Hydrogen bonding is when you have a polar force that has a more particular bonding to it. Hydrogen bonding molecules also have dipole-dipole and also have dispersion. So keep that in mind. So with dispersion forces, we have some examples. These are all non-polar molecules. We know this because they have all the same element around the central atom, and the shape is not bent or trigonal pyramidal. Both of those shapes were talked about as always polar due to their imbalance of lone pairs of electrons. So this is only force for nonpolar, but all molecules experience these forces. Okay, all of them do. And you can see we have all the same around here, therefore all nonpolar. Next in line, dipole-dipole forces. These are polar molecules, whether it's like a linear with two elements bonded, another linear with multiple elements that are around the central atom, or something that was like tetrahedral, where we'd have an imbalance of charge. So again, these are different elements around the central atom. Could also be the shape bent or trigonal pyramidal. An example though here is tetrahedral, which can be polar again because we have some different elements around the central atom. This is the force for all polar molecules. These again would also have dispersion forces. Hydrogen bonding, also polar, but we have particular elements bonded together. So this is when we have fluorine, nitrogen, or oxygen in the molecule bonded to a hydrogen. Now that's the key. It needs to be bonded to the hydrogen. It can't just be in the molecule somewhere. So you can see from these different examples, we have bonds between. This is the strongest intermolecular force and would include dipole-dipole and dispersion forces as well. So it's pretty critical that you can identify what type of intermolecular forces are present, because that will affect the properties that these will have. In our final thoughts, here is our joke. Two people meet from the newest chemistry dating app, Chemistry, on their first date. One wearing a shirt that says polar and another wearing a shirt that says non-polar. They both agree that the chemistry isn't right and go their separate ways. Be sure to answer the final question about how this might affect properties, thinking about attractions and how things come together, and coming with your thoughts. See you soon. Bye-bye.